Students, let us take one more example. Question number 12. Magnetic effect of current. It is about two parallel conductors and the force that it will experience. Two long parallel current carrying conductors are 0.4 meter apart in air. Carries a current of 5 ampere and 10 ampere respectively. Find the force per meter on each wire if currents are in the same direction and opposite directions. The changing the directions in the current will not change the magnitude, only the force will be attractive or repulsive. So first let us draw I'm not going to write the equation, I'll just write the physical, I'll just write it physically, I'll draw the diagram and make you understand what is the question. So there are two parallel conductors carrying current 5 ampere and 10 amperes respectively. Suppose that this is 5 ampere and this is carrying a current of 10 ampere. Okay, two conductors infinitely long, so this goes up to infinity, goes up to infinity. The distance of separation between them that I call x, which is given as 1.4 meter. Okay, now how much force each conductor will experience, because it is action reaction force, so each forces will be equal in magnitude on whether the force experienced by the first conductor or the second conductor. If it experiences a force of 5 Newton, this also will experience a force of 5 Newton. This force we are going to find. Force on each conductor. Now, the two conditions are the currents in the same direction and current in the opposite direction. So this diagram shows that the current are in the same direction, whether it is toward or from this side to this side, or this side to this side, or downward. If I reverse the direction of current in both the cases, then also that would also mean that they are in the same direction. It hardly matters, the magnitude will remain the same. So from down towards off, the current is flowing in the first conductor and the second conductor. The current are 5 and 10. The force that experienced by each of the conductor that you would write, and we know the formula for the force experienced by two, force acting per unit length. So per unit length of this conductor or this conductor, the force that it will experience is mu 0 upon 4 pi to product of the currents divided by the distance of separation. This is the formula. So the force experienced per unit length is, unit length means 1 meter, say in this case, will be this value. So to solve this value, we'll write this equals to 10 raised to minus 7, because mu 0 upon 4 pi is 10 raised to minus 7, is a fixed data, it's not going to change in the universe. So two product of the currents are, this is I1 say, this is I2 say. So therefore it is 5 into 10 divided by x, 0.4 meter. So if you put the units also, check the units, it will be Newton per meter. So now it is 4, the 10 goes up, 10, 10, 100, this is also 10, okay, and this 4 is here. So solve it. This is 10, 10, 10 raised to minus 5, so 1 10 goes up, so it is 10 by 4 into 10 raised to minus 5, okay. So this is 2.5 into 10 raised to minus 5, okay, 2.5 10 raised to minus 5 Newton per meter. So this is the answer to this question. In case the forces are in the same direction, they will attract each other. The force will be this side and this side, attractive. If the direction is reversed, that means if one conductor the current is up and the other is down, then they will repel, okay, but the magnitude will remain the same, that is 2.5 10 is to 1. Here also the force will be 2.5 minus 5 Newton per meter. Per meter, this is the force experienced. If this conductor is supposed of 5 meter, then you multiply 5 here. if this conductor is of 10 meter length, multiply 10 here. So if you multiply 10 here, then it's 25 10 raised to minus 5 Newton that the conductor will experience. Okay. Next is, let us take one more question. Question number 13. It says that two wires 20 meter long and 10 centimeter apart. Two wires 20 meter long. This is 20 meter long. Distance of separation is 10 centimeter. Carry a current. Find the current through each wire. If a force on each wire is to be 0.02 Newton, the force experienced by each wire is 0.02 Newton. The question is, there are two conductors parallel. The distance of separation x is 0. Is 10 centimeter. 10 centimeter. Here the current is suppose I1. Here the current is suppose I2. This is suppose 20 centimeter long, and this is suppose 10 centimeter long. Find the current through each wire. That means you have to find I1 and I2. If they have to experience a force of the force they are experiencing here, they're in the same direction, so it will be attractive in nature. So both the forces will be same. So the force they are experiencing is 0.02 Newton. So for what value of current, the force is this. Now the question is that because this equation, let us analyze it. We know that in a parallel conductors carrying current, the force per unit length is mu 0.4 pi 2 times product of the currents divided by the distance of separation. Okay. Now this is a force to 0.02 length is given. When the force per unit length is 0.02 Newton, then what about the currents? This is one equation. You should have one unknown, but you cannot find the current I1 and I2 from this equation. So that means we have to assume that I1 and I2 are same, and that is I. If this is the case, then only you can solve this question, otherwise you cannot solve the question. So if nothing is given, we have to assume that the current in both the wire is same. Okay. If that is the case, then force per length will become mu 0.4 pi to I square divided by x. Now you can put all the values that is available and then solve it. So I will just put the values. I will take I square on one side, and because I want I, so I will keep this as subject and other as object. So I square is f by L 4 pi upon mu naught x by 2. So putting the values, this is 10 raised to 7, x is 10 centimeter, so it is 10 into 10 raised to minus 2 meter divided by 2. This force is 0.02. Okay. A is okay. Find the current to each of the wire. The force acting on this is this. What is this? A 2 pi I1 I2. Two wires of 10 20 meter long and 10 centimeter. Two wires are 20 meter long. So this is actually 20 meter and 10 centimeter apart. Okay. So this is not 10 centimeter. This is 20 meter long. So you put divided here by 20. If you solve this question, how much you'll get? This comes out to be cancels 2 here. So 2 by 100. So this 2 will also cancel 1 by 100. This is 100 here. And this 2 will cancel, this will 5 here. So this will cancel, this will be 3 here. So 1 by 2 into 10 is to 3. So this is 0.5 and 10 is to 3. So this is I square. So I will be under root of 0.5 10 to 3 ampere. This is the answer to this question. Okay, thank you.